In figure, I think we also did
We
question
finished question number 2.
third, right? Third we have to do. So diagonal AC and BD of a trapezium. So let's draw a trapezium first of all. Yes, Hamna, can you hear me? Hamna?
Yes, ma'am.
Okay. So please just roughly draw figure A, B, C, D is a trapezium. So note down whatever is given. So it is given that AB is parallel to DC. Just a minute, let me use my whiteboard. I don't know. I'm not able to write here properly. So ABCD is a trapezium. So write down what is given, that line AB is parallel to CD. Intersect each other at point O. So diagonals you have to draw. And they intersect at point O. Using a similarity criterion for two triangles, show that. So to show OA upon OC is equal to OB upon OD. Okay, so let's show. Now, where should we start? We always, first of all, see what exactly I have to show. OA upon OC. So OA is this, right? And OC is this. And then OB is this and OD is this. So which two triangles I can take here? And I have to use similarity criterion. Clear? So if I somehow show that the two triangles are similar, so therefore I can write this thing. So which two triangles I need to show here which are similar? So I see O and OC are part of which triangle? So can I take, this triangle and this triangle? Yes?
Yes.
Okay. So let us try to show that these two are similar. So in triangle OAB and triangle OCD, let us try to show. What can I use here? Now you will tell me which criteria. Can you see something equal here? Now here you will make use of the given condition, right? Now see, AB is parallel to CD. That means they are two parallel lines and they are basically transversals which are cutting. So ultimately this angle is equal to this angle. You have already studied this in class 9th.
Yes, ma'am.
Yes, angle if
Yes.
I call this 1 or 2. And similarly, this angle 3 is going to be equal to this angle. Which kind of angles they are?
Ma'am, alternate angles.
Yes, alternate angles are equal. So I can write angle, either you can write in words like in ABO is equal to angle ODC. Clear? And also angle third and fourth I'm writing. So OAB is equal to angle OCD. Is that okay? And both are which? Alternate interior angles. Yes, Rida?
Yes, ma'am.
Yes, you know what are alternate interior angles, I hope?
Yes, ma'am.
Yes, okay. And so two angles are equal. Now, what are the four criteria? Please tell me. One is AAA. Then you have what? So AA is actually part of this only. Now, what is the third? Other one I have?
Ma'am, SSS.
SSS similarity, and there's one more criteria which I told you.
SAS.
SAS or ASA?
SAS.
SAS. So please note this in your mind. Don't use ASA here, right? ASA is not for similarity. It's actually for congruency. So two sides have to be equal. Okay. Now I can use AA here directly, but AAA also I can use because ultimately these two angles are also equal, isn't it? What kind of angles they are? It is clearly visible in the figure that they are equal.
Vertically opposite angle.
Vertically opposite angle, yes. So I can write angle AOB is equal to angle DOC, which is vertically opposite. So all the three angles are equal. Okay. So by A criteria, similarity criteria, okay. So which triangle is similar to which? Now you will name the triangle. If I start from A, okay, is similar to. So which angle is equal
AOB
to?
similar to COD.
Exactly. So because angle A is equal, like angle 3 is equal to angle 4. So I'll start with C here. Understood? So AOB is equal to COD. That way you have to write is similar. And now because they are similar, so the corresponding sides are in proportion. Therefore, corresponding sides are in proportion. Sides are in proportion. And hence, so if I take the side of one triangle, AO, so I have to take OC, right? So if I'm taking this side, so this side will be proportion to this one, right? So that's how I'm naming it, that AO will be proportional to OC. That's what I told you, right? And this will be OB. So if we take these two, so it will be proportional to OD. So that's how we name the triangle. So OB upon OD. So hence proved. Please write down. Then next question, fourth one.
Ma'am, done.
Done. Okay. Now next question, fourth. So fourth, like it's a good question. In figure, the figure is given. I'm just again drawing it here. So right now you can also roughly draw it in your copy. It's there in the book. Okay, anyway, it's a rough figure. So T, Q, and this is R. And now this is S and P, right? Now, which are angle 1 and 2? So this is angle 1 and 2 is, I think, the complete angle, right? No, this much. Yeah? Yeah, this is 2. Okay, so I have just drawn it very badly, but anyway, this angle is 2, not the complete one in the figure if you look carefully. So start whatever is given here. Okay, this something is given that OR upon QS, note it down. OR upon QS is equal to OT upon PR. Okay, and
It's Q, right?
OR upon QS. Yeah, it's my Q. Okay. Okay, that's how I write my Q. Yes.
It's not OR, it's QR.
Oh, yes. In the numerator. Okay, okay, fine. And it is given that angle 1 is equal to angle 2. Okay. You have to show that triangle PQS is similar to triangle PQR. Okay. Now, what is PQS? First of all, see here. PQS, that means this much, right? Okay. TQR, what is TQR? The complete one. So this triangle is similar to this complete triangle. Understood? Okay, the figure has got messed up, but I hope it's clear now. Yes, this is angle 1. So let's start the proof. We start from the given condition. So one thing is given that angle 1 is equal to angle 2. I mean, we have to make use of everything which is given to us. So if we make use of this condition, so what can I conclude? If angle 1 is equal to angle 2, now look at the triangle PQR. Angle 1 is equal to angle 2. So what can I say about the sides of this triangle? So can I say, yes, Amna?
QP is equal to PR.
Yes, very good. PQ is equal to PR. The sides which are like sides opposite to equal angles are also equal. Yes. So you will write this thing in the bracket. Sides opposite to equal angles are equal. So this is from previous classes, you know. Let me just call this equation number 1 because I can use this result somewhere. So let me give it some name, equation number 1. Now come to the second given condition. So again, it is given that QR upon QS is equal to, again, it was QT, not OT. I'm sorry, Rida. So QT upon PR. So what can I do here from this given condition? First of all, I'll replace PR. No, yeah, PRS. This from this, can I replace? So this will become QR upon QS is equal to QT upon PQ from FON. So I have just used this result here. Clear? Okay. Now, just see QR and QS are part of which triangle? QR and QS, and I have QT upon PQ. So let's take our two triangles which we want to show similar, right? Let's see what 3 things we can show here. Now, in triangle PQS and triangle TQR. So what can I show here? PQS is the yellow triangle in the figure. TQR is the green triangle in the figure. So angle 1 is part of both the triangles. Yes? Yes, Rida?
Yes.
If you look at the yellow and green triangles, angle 1 is part of both the triangle. So ultimately, I can write angle, if I yellow, that means PQS is equal to green means angle TQR. Yes?
Yes.
Okay. I can write common angle. Okay. Now one thing I have common. Then I make use of this thing which I have shown here, that QR upon QS. So QR is, your green triangle. QS is your small yellow triangle. Then here I need the side of green triangle in the numerator. So that means QT, and yellow triangle, that means QP. Clear? So that means the sides are also in proportion. So which criteria I can use here?
Yes.
SAS. Yes, two sides are in proportion. One angle is equal. So by SAS similarity criteria, triangle PQS is similar to triangle TQR, and this we were supposed to show. Please write it down. Yes, written, both of you?
Yes, ma'am.
Okay, let's come to the next question. Question number, what, 5th, right? Now, S and T are points on side PR and QR of triangle PQR. So first of all, you draw a triangle PQR here, because the figure is not given. So let's take P, Q, and R, right? Now, S and T are all points on side PR. So if I take a point S here and T on QR, so let's take T here, something, such that join them. Angle P is equal to angle RTS. So which angle? Angle P is this and RTS is this. Okay, so this angle is equal to this. Getting it? Let me call it 1 and 2. Clear? Show that. Note down what is given, that angle 1 is equal to angle 2. And to show that triangle RPQ is similar to triangle RTS. Okay. RPQ, that means the complete triangle, is similar to RTS. That means this is small triangle. Is this clear? Figure is clear?
Yes, ma'am.
Okay. So big triangle is similar to the smaller one, that you have to show. Let's do the proof. So start from the given condition. Let's say, okay, first of all, look carefully. What can I do here? Because I want to show that triangles are similar. So that means I need to show some criteria for similarity. So what do I have here? See, angle 1 is equal to angle 2. One angle is given to be equal. Is there anything
Ma'am,
else?
angle R is common.
Exactly. Angle R is common. Is there anything else? So let's start that in triangle RPQ, okay, and triangle RTS. Okay, so right now you can see, okay, anyway, both the triangle. Angle 1 is equal to angle 2, which is given. Okay, so one angle is equal. Now angle R is common. So angle R is equal to angle R, which is common in both the. So two angles are equal. I can use AA criteria. So ultimately the third one is going to be equal. Yes.
Yes, ma'am.
So by AA similarity criteria, so if I write angle RPQ will be similar to triangle. So because angle R is part of both, so I'll start R here because angle R is equal to angle R. Then just check whether we are writing clearly or not. Angle P is equal to angle P. No, angle P is equal to angle this 2. So T of the small triangle. So if I write P here, I'll write T here. So then Q and S. Is that okay? I mean, when you name the triangle, just be a little careful about it. Okay?
Okay.
Yeah. So just check like this because R is actually same in both. So angle, if I am writing R first, so here also R first. Then for the big triangle, which is my angle P, for the smaller one, it is my angle T, which are equal. So if P is on the second place, T on the second place, and then the other third point. Third vertices, I mean. So this is a simple question. Let's do the sixth one now. In figure 6.37, okay, so figure is given. Let's draw it. Okay, write down what is given here. If triangle ABE is similar, congruent to triangle ACD, okay, this is given that triangle ABE is congruent to triangle ACD. So look carefully what is ABE and what is ACD. So ABE means this one, right? This one, ABE, and similarly you have this ACE. Getting it?
Yes,
Okay.
ma'am.
And to show that triangle ADE, so which is ADE? Okay, the top one, ADE is similar to triangle ABC. Okay, that's good. So one thing I can clearly see, angle A is common in both, right? I can see from the figure. Ultimately, you know, I want to show this triangle to be similar to this. So angle A is, I can see here that it is common in both the triangles. Yes, Amna?
Yes, ma'am.
Okay. So let's start with the congruency, which is given, and what I can conclude from here. So ultimately, I want to show similar. That means I'm going to use some similarity criteria, right?
Yes.
So do the question like this. I want to show them to be similar. So that means I need a similarity criteria. Now, what are the three similarity criteria? First of all, like write it down. Then SAS and then SSS. Right. Now, one angle is clearly common to both. Yes.
Yes, ma'am.
Okay. So that means this is gone. Now these two. So ultimately, I can also show AAA here. I can also show SSS because the congruency is given. So I'll do it like this. Proof. Now, since these two triangles are congruent, now triangle ABE is congruent to triangle ACD. Congruent means the corresponding angles are also equal. The corresponding sides are also equal. So by CPCT, what can I write? By
AD is equal to AE.
Very good. So first of all, AB, what you said, AB is equal to AC, right?
AD is equal to AE.
Yes, also. A, AD, okay, AE is equal to AD. Because see, Rida, if I am taking ABE on the left hand side, so ABE is having side AE, right?
Yes.
So that is, so I'll write AE here and then AD here. So correspondingly, I'm writing. So I've got two sides equal. No, AB is equal to, wait, if I want to show the two triangles to be similar, Okay, now if I just flip it, that means AD is equal to AE, right? This is my 1 and this is my 2. If I just divide, see what I'm trying to do is if I divide 2 by 1, so how can I write it? I write AD upon AB is equal to AE upon AC. Is that okay?
Yes.
Now see what I'm doing here. See what is AD? AD is this is small side. That means it is part of triangle ADE, right? Because I want to show this triangle to be similar to this. So I'm just trying to show that their sides are in proportion. So AD upon then the complete side AB, right? Is proportion to this small AE upon the complete side AC. Is this clear, Hamna?
Yes, ma'am.
Yeah, okay. So the sides are in proportion. So now I'll write that in triangle ADE. So I take the small triangle and the big triangle and ABC. So angle A is equal to angle A, which is common. So one angle is equal and the sides are in proportion. So AD upon AB is equal to AE upon AC. So which criteria I can use?
SS.
SAS. So by SAS similarity criteria, I can write, I can write triangle ADE is similar to triangle. Now be careful while writing because angle A is equal to angle A. So start with A. Okay. Now because AD upon AB, look here. So if I take AD here, so I have to take AB here. Getting it? And then E and then C. Is that okay? So be careful while naming the triangles. So this ratio, if you are taking AD here, so AB has to come here. That's how we write it. Please note down, then we will do question number 7. So have you written?
Yes, ma'am.
Now come to question number 7, which is having 4 parts. So I can take up, I think, one or two. Now in figure 6.38, okay, figure is given. Oh, that's the figure. Now, note down what is given here. Altitudes AD and CE of triangle ABC intersect each other at point O. Show that. Okay, first thing. So it is given that, angle 1 and angle 2 is 90 degree. Altitude means this thing. So AD and AE are altitudes of triangle ABC, and that is given. Now to show first part, that triangle AEP is similar to triangle CDP. First of all, clearly see what is AEP in the figure. AEP. Yeah, what is AEP? AEP means this one. Yes. Is similar to CDP. That means this one. So ultimately, I have to show some similarity criteria. So what can I use? Anything you suggest? So take these two triangles first of all, and triangle AEP and triangle CDP. Okay. Now what can I use here?
Ma'am, angle APE is equal to CPD.
Okay,
They
why?
are basically opposite angles.
Exactly. APE is equal to angle CPD, vertically opposite. Good. Yes, Rida, what else I can use?
AEP and angle CDP are 90 degrees each. So
Exactly. Yes, AEP is equal to angle CDP. Okay, is equal to 90 degrees each. Good. So two angles are equal, that's enough. So by AA criteria, you can write the third one if it's clearly visible in the figure, otherwise no need. Just write AA criteria of similarity, because ultimately it's going to be equal. These two triangles are similar. So triangle AEP is similar to triangle. Now angle A will be similar to
CDP.
which triangle? Yes, C, because E is C, yeah, CDP. PP, yeah, same. Okay, so note down, name the triangle properly. So this is done. And second part, if we see what we have to show, that triangle ABD, which is triangle ABD here. ABD is similar to triangle CBE. Now, which is ABD? ABD, okay. So please see ABD in the figure. Yes, so ABD means this one, right? And CBE is this one. So what can which criteria I can use here? Let us take the two triangle first of all. So in triangle ABD and triangle CBE, yes, Rida.
Angle ADB is equal to angle CEB because 90 degrees.
Exactly. Angle
AD,
ADB, yes, is equal to angle CE.
CEB.
Good. 90 degrees each. And
Ma'am, angle B is common.
exactly, angle B is equal to angle B, which is a common angle. So two angles are equal. So again, by AA criteria, triangle ABD will be similar to triangle. So yeah, now name properly here. So you need B in between, and then
CBE.
CBE.
E.
Angle DE, yes. So it is, yeah, and the question also, I think it's given accordingly. So this is also proved. I think two parts I'm leaving for you. You can do that now. Let's come to question number 8. Written, both of you?
Yes, ma'am.
Okay, let's do question number 8. The other two parts are almost similar. You can try on your own. Now the figure is not given. So E is a point on the side AD produced of a parallelogram ABCD. So first of all, you draw a parallelogram ABCD. A, B, C, and D. Okay, E is a point on the side AD produced. Now, which is AD? That means you have to produce your AD here, and then you have some point E. Yes. Okay. And BE intersects CD at F. So that means you have to join BE and it's going to intersect CD at F. Show that. So to show, triangle ABE is similar to triangle CFB. So which triangle? ABE. ABE, okay, CFB. All right. Now, what was given? That ABCD is a parallelogram. So you can write properly. It's short, I've written. Okay, so what can I use here? Just think a little bit about it. So clearly see what is ABE in the figure and what is CFB in the figure. So what can I write here, Hamna?
Ma'am, angle A is equal to angle C.
Why?
Ma'am, opposite angles of the parallelogram.
Okay, very good. Now we make use of the given condition because ABCD is a parallelogram. So angle A is equal to angle C. Opposite angles of a parallelogram are equal. Yes, good. So one angle I have got. Now what else I can write here? I think one more angle I need.
Ma'am, angle CFB is equal to angle ABE.
Sorry. Again say.
Angle CFB is equal to angle ABE.
ABE. Why do you think so?
Ma'am, because they are alternate interior angles. Like if AB and DC are parallel lines, so BE is a transversal.
Yes. EB is the transversal, which is cutting the line AB and CD. Yes, I think it's right. Yeah, Rida, what do you think? Is it right?
Yes, ma'am.
Yeah, that also we can do. So if I call them angle ABE is equal to angle BFC. Okay, what is the reason? Right here, like since AB is parallel to CD. So therefore, because they are alternate interior angles. Clear? Okay, so AA criteria by AA criteria. Now name the triangles. So triangle ABE will be similar to triangle. Now, which angle is equal to which? A is equal to C. Okay. Then B is F. Okay, here. And then the other one, E and B. Yes. Yes, Rida, have you written?
Yes, ma'am.
Okay. This question can also be done like this, like instead of showing this angle, like for example, we have shown angle 1 is equal to angle 2. You can also show this thing. The other remaining angle you can also show that 4 and 3, for example. This is also equal because you know AD is parallel to BC and AE is actually AD extended. So that means ultimately AE is parallel to BC. And again, angle 3 is equal to angle 4, which is again alternate interior angle. So any angle you can use, or you can show all the 3 angles if you wish. So A criteria you can write. So both way it can be done. Okay. Now question number 9. So this was actually simple. I think all the questions are simple. You just have to look very carefully at the figure. And obviously the theorems should be clear in your mind. Let's do 9th. Okay, in figure. So figure is given here. ABC. Let me draw the figure first of all. Sorry. Yeah. ABC and AMB are two right triangles, okay? Right angled at B. So that's a right angle. And M respectively. Prove that first. That triangle ABC is similar to triangle AMB. Proof. So we take the two triangles which we want to show similar. So triangle ABC and triangle AMP. Yes, Hamna. What can I use here? First, see what is ABC and what is AMP. So ABC, if I'm saying, so that means this angle I need, right? ABC.
Yes, ma'am.
Okay. And AMP. So this angle, AMP. And both are 90 degree. Yes.
Yes, ma'am.
So I can write angle ABC is equal to angle AMP. 90 degree.
And angle A is common.
Yes, angle A is common. So two angles are enough. So by AA criteria, you can write by AA criteria of similarity, the two triangles are, so I'm writing ABC will be similar to triangle because angle A is common. So I will start with A. Then B means I'll use M here and then B. So similar. Now second part. So you have to show that CA upon PA is equal to BC upon MP. Okay. Now what is CA? Okay, CA upon PA is equal to BC upon AP. So we will use the result of first because we have already proved that these two triangles are similar and therefore their sides are in proportion. Yes.
Yes, ma'am.
Okay. Now, since we have proved that your triangle ABC is similar to triangle AMP, therefore, the ratio of corresponding sides is proportional, or the corresponding sides are in proportion. The corresponding sides are in proportion. Right. So therefore, you can write that CA upon, so carefully use, if you are using CA side of this, that means CA is opposite to the 90 degree angle side. So you will use AP for this one, right? And if you are using BC from here, that means it is the 90 degree angle side. So MP here. This is what you were supposed to prove. Yes. Yeah, Rida, any confusion?
No, ma'am.
Okay. How many questions are there? 16 questions. Okay, let's do the 10th one quickly. I hope you have written.
Yes.
10th question. CD and GH respectively. Okay, the figure is not given here. So CD and GH are respectively the bisectors of angle this of triangle. So two triangles you have to draw. Draw two triangles first. Right. So one is ABC, let's say ABC, and other is EFG. ABC, FEG. Anywhere you can start, you know, EFG. Right. Now CD and GH respectively are the bisectors of angle ACB. So you know this angle, its bisector is this. So I'm just bisecting this angle. So CD is the bisector of this angle. And similarly, GH is the bisector of this angle G. Clear? Such that D and H lie on the sides, okay, respectively. If triangles are similar, show that. So it is given that triangle ABC is similar to triangle FEG, right? Now look here one thing. Both of you, please see, because it was already given in the question that this is similar to FEG. That means angle A is equal to angle F, right? Now come here. When I draw the second triangle, instead of naming it, I can name it like this, EFG, no problem. But you know, this angle, try to understand this thing, ABC. So this angle is actually equal to this angle. So instead of creating confusion, what I have named it like this I have given name A. So I've started from here, E, F, and G. No problem. Yes, Rida.
Yes, ma'am.
Have you got the point?
Yes, ma'am.
Okay. So if I'm using A here, so I have named it like this, E, F, G. Fine. What is given is this, and what you have to prove to show that CD upon GH is equal to AC upon FG. So Hamna, any idea what can I use here? What can I do here?
Ma'am, angle A equal to angle F.
Why?
That's given.
Yes, it's given that the triangles are similar, right? Okay, so
And
if we take the two triangle, first of all, let's take the triangle. Which triangle should I start with?
Ma'am, and triangle ADC and FHG.
Okay, let's before coming to similarity, let us see what else we have. So first of all, since it is given that triangle ABC is similar to triangle FEG. So that means it is given that angle A is equal to angle F, as Rida was saying. So let me call it my result one.
half
Okay.
angle C is equal to half angle G.
Exactly. So ABC is similar to this. So that means angle C is equal to angle G. Yes. So that means half of angle C is equal to half of angle G. Yes, Amna.
Yes, ma'am.
So if I give them name, let's say this angle is X, the half one, and this angle is Y, the half one. So that means angle X is equal to angle Y. See, ultimately, Hamna, I need CD upon GH. So this is CD and this is GH. And then I need AC upon FG. So AC upon FG. So that means I need this small triangle to be similar to this small triangle. Clear?
Yes, ma'am.
So that is why I'm taking, so one angle I have got to be equal. And then angle X and angle Y is coming out to be equal. So ultimately, these two triangles are similar by AA criteria.
Yes, ma'am.
Okay, so now name them. So in triangle ACD and triangle FGH. Now what do I have? I have angle X is equal to angle Y, right? From second result. And then I have angle A is equal to angle F from first result. So therefore, by AA criteria, these two triangles are similar. ACD is similar to triangle FGH. And because they are similar, so the sides are in proportion. Therefore, sides are in proportion. And therefore, I can write CD upon GH is equal to AC upon FG. Okay, second part you will do on your own. Written, both of you?
Yes, ma'am.
Okay. Now, yeah, now come to the second part. I think same, yeah. So same figure. Now what you have to show in the second part? Okay, second part you have to show that triangle DCB is similar to triangle HGE. Which is DCB? This, yellow one, DCB, and this is similar. How can you do it? So one angle is same. Angle B is equal to angle E. So I'm just giving you hints, right? You can write it properly. So angle B will be equal to angle E. One angle same. What else I can use here? And this time, other half will be equal. You give me some name, Z and S, let's say. Angle Z will be equal to angle S. Yes? Yes, Rida.
Yes, ma'am.
Because angle C is equal to angle G. So half of angle C is equal to half of angle G. So I'm taking the other half this time. So give it some different name. So angle Z will be equal to angle S, and AA criteria, the two triangles will be similar. Got it?
Yes, ma'am.
Okay. Third part, DCA is similar to HGF. DCA, that means this is small one, is similar to DGF. So here you can make use of the result of the first.
Yes, ma'am.
Yeah. So please complete question number 10. Still some questions are remaining. So I think one more, and I'll give you a few practice questions in the next class. 6.5 is not in the syllabus. Exercise 6.4 and 5 are not in the syllabus. Okay. I'll just check again. So you can leave the class now, both of you. Please complete question number 10. In the next class, we will complete triangles.
Thank you, ma'am.
Okay, thank you. Bye. Yes, Hamna, you can also leave.
Thank you, ma'am.
Okay, bye. Yes, Sarah, can you hear me now?
Yes, ma'am.
Okay, welcome to the class, Sarah. So what were we doing in the last class, Sarah?
Triangles.
So how much I did with you? Triangles, tell me. What exactly I did in the last class?
The what is it? Similarity.
Yeah, similarity I was doing, but which exercise, which question, which theorem, what was I doing?
6.2 and that Thales theorem.
Thales theorem. So have I done the proof of the theorem?
Yeah.
Okay, I have completed the proof. Fine. And the converse, I think we also discussed about the converse of the theorem, right?
Yeah.
So today we have to start with the exercise. I think question number 1 also we discussed.
Yeah, 2 also.
2 also. Let's come to question number 3 then. So in figure 6.18, so you have a figure. So Sarah, have you started doing your together with book?
Yes, ma'am, a little. But now still, since I'm having exams, so I'm not doing that much.
So which exam you have now? When?
Science on Monday.
Science on Monday. Okay. Yeah, but please like do at least 5 questions every day from it.
Yes, ma'am.
Just try to don't skip it. It's okay you have another exam, but don't skip your maths practice.
Yeah.
Okay, that's the figure. So I'm using different colors.
Which question are you doing?
Third question. Oh, sorry, the figure is a 4th I've drawn.
Third question, ma'am, we have to do second question.
You have to do the second one?
Yeah.
Okay, fine. Question number 2. E and F are points on side PQ and PR respectively of triangle PQR. So first of all, you need to draw a triangle PQR here. E and F are points on side PQ and PR. So on side PQ, you have some point E, and then here you have F. For each of the following case, state whether EQ is parallel to QR. Sorry. Now, first case is this some. Okay, I'm using the figure only. So PE is given 3.9 centimeter. EQ is given 3 centimeter. PF is given 3.6 centimeter. FR is 2.4 centimeter. Yes. Now you have to check whether EF is parallel to QR. So which theorem I can make use of here, Sarah?
Thales theorem.
Thales theorem. So I'll try to show that the sides are in proportion, and if they are in proportion, the lines are parallel. Basically, this is the converse of Thales theorem, not the Thales theorem.
Yeah.
Yes.
Yes, ma'am.
In Thales theorem, the line is already parallel. Just a minute. Just a minute. All right. So in the theorem, Sarah, the line is already parallel, and the result is that the sides are in proportion. And here we will check if the sides are in proportion, then by the converse of the theorem, the line will be parallel. So let's check the ratio here. So PE upon EQ, let's see how much is it?
this is 3.9 centimeter and EQ is 3 centimeter, right? So
Yeah.
centimeter will go away. So only 3.9 divided by 3. And if I remove this decimal, so I'll just multiply the denominator by 10. Yes?
Yes, ma'am.
Okay. Now 3 into 1, 3 into 1 and 3. So I'm getting 13 upon 10. Okay, let's check the other side. So PF upon FR. Let's see what I'm getting. So this is 3.6 centimeter divided by 2.4 centimeter. Clear?
Yes, ma'am.
So again, centimeter will go away. And if I remove the decimal, so I have 36 divided by 10 and into 24 divided by 10. Is that okay?
Yeah.
Okay. So 10, 10, basically they cancel out. Now both are even, I can use the table of 2. So 2 into 1 and 16, that means 2 into 8 and 12. Again, I can use the table of 6 directly. 6 into 3, 6 into 2, 3 by 2 I'm getting. So do you think the sides are in proportion?
No.
No, obviously no. This is 13 by 10. This is 3 by 2.
Yeah.
So you say that PE upon EQ is not equal to PF upon FR, and therefore EF is not parallel to QR. Or we write it like this also. EF is not parallel to QR. That's also we write it.
Yeah.
Please note it down.
Done.
Okay, now do the second part right now and tell me. Is the side parallel or not?
Ma'am, the down thing EF
Hmm.
is not parallel to QR, right?
Yeah,
That's what you made.
you don't write it, just write like this, no problem. It's just a word. EF is not parallel to QR because the sides are not in proportion.
Should I send you this question?
Yes, if you can, please do the calculation and send me.
No, I'm done. I will send now.
Okay, so are they parallel or not?
They are parallel.
They are parallel, okay. Please do the third one also very quickly.
Third part, I mean.
Then should I send it that and this together?
Just do it now. If you have sent me the picture, no, not yet.
And I'll send both of them together.
Okay, fine. Do it. So please tell me when you were done with the question.
And I'll send now both of them.
Okay, let me see. I have not received.
I will send now.
Hmm, 8 by 9, 8 by 9. And the third one, 64 by 9. How you are getting 64 by 9, Sarah, here?
By dividing?
So where is the calculation? Sarah, are you using calculator?
Yes, ma'am.
But Sarah, if you will use a calculator, who will help you in the exam? See, I don't want speed. You take half an hour on the calculation, but do it with your pen on your own. Okay. That's how we learn how to do calculation, isn't it?
Yes, ma'am.
So again, do it. Like, stop using. Show me each and every step you are writing. You are removing the decimal. Everything you have to write properly, the way I write on the screen.
Yeah.
Never use calculator, Sarah. This is not the age to use calculator. This is actually the age to learn how to, how to do calculations, how to learn the tricks of calculation. So use your mind. I want you to learn, okay? See, I already know how to do calculation. I have already passed my class 10th. So it's for your benefit. I'm asking you to do calculation. Getting it?
Yes, ma'am.
Mm. do the third part and show me how you are getting the result. Each and every step you have to write.
Okay, ma'am.
If you have any problem, Sarah, just let me know. We can solve it together. So,
Yes, ma'am.
so should we solve it together? Okay.
Yes, ma'am.
Let's do the third part. Now see how we do calculation. Okay. Stop. Just keep your calculator away, please. I don't want exact answer because my job is not to assess you that you are right or wrong. My job is to make you learn, right?
Yes, ma'am.
Okay. So what is given? PQ is given. Okay, sorry. Let me see. PQ is 1.28 centimeter and PR is how much? 2.56 centimeter. Then PE is given
0.18.
0.18. So I can directly write here 0.18. This is PE.
And PF is equals to 0.36.
0.36 centimeter. Okay. So in this question, this complete side is given, right? But you need this much. So you have to do one step extra first of all. How can you get EQ? Simple. I mean, your EQ is your complete side PQ minus PE, isn't it?
Yeah.
This much is already given to you. And the complete side length is already given to you. So if you subtract this much part, so you will get the remaining EQ, isn't it?
Yes, ma'am.
So first of all, find out how much is EQ. EQ is PQ, that means 1.28 centimeter minus PE, which is 0.18 centimeter. Okay, now tell me, what is the answer here? Don't use calculator, please.
1.10 centimeter.
1.10.
Yeah.
Okay, 1.10 centimeter. Okay, that's right. So you have got EQ. Okay. Similarly, you will find FR on the other side. So let's check the left-hand side ratio. So I want to check PE upon EQ, right?
Yes, ma'am.
PE upon EQ. That means PE is 0.18 centimeter and EQ I have found 1.10 centimeter, right? So
Yeah.
first of all, this centimeter will be gone. So you will be left only with numbers 0.18 divided by 1.10, right?
I mean, it must still write the centimeter.
Yes, I mean, in the answer, you are not going to get centimeter. So see, this, try to understand, Sarah, this sign means nothing. This sign is actually, it's a representation only that this thing is gone now. Okay. It's not a
Yes, ma'am.
mathematical symbol. Getting it?
Yeah, ma'am.
It's just to make things clear in your mind that this thing is actually gone now. Okay. It's not a mathematical symbol. It's just, we use it for our convenience. That's it. That's all I can say. All right. So that centimeter is gone. So only numbers have remained now. How to solve it? First point is to remove decimal, first step. So you have, like, after two numbers, you are having a decimal. So this 18 will be divided by 100. Clear?
Yes, ma'am.
Similarly, in the numerator, you have 10 and it will be divided by 100, isn't it? After two places, you are having a decimal.
Yeah.
Okay. So obviously 100 will also be gone now. Only 18 divided by 10 will remain. You can convert it to decimal also, 1.8, or you can divide by 2. So 9 by 5 you are getting. So now you are getting 9 by 5. Yes? Now check other ratio and tell me, send me the calculation similarly. First of all, find the value of FR, then check the ratio PF upon FR.
Once again.
Yeah, first of all, you find out this side because it is not given. Yes. Like this, you have to do.
No.
And then check the ratio PF upon FR and send me the calculation right now.
Ma'am, first I need to find the FR, right?
Yes, because it's not given. So how will you find?
2.56 minus 0.36.
Yes, good. So basically PR minus PF.
2.20.
2.20.
Yeah, 2.20.
So FR is actually your complete side PR minus of PF. Okay. So
Yeah.
that means complete side is 2.56 centimeter minus 0.36 centimeters. So you are getting 2.20.
Yeah.
Yes. Okay. Fine. Good. Now find the ratio.
Yeah. No, just 1 minute. Ma'am, how should I split 2.20?
2.20. Basically now you are finding the ratio PF upon FR, right?
Yeah.
Okay. How much is PF?
3.6, 0.36.
0.36 centimeters. Okay.
Yeah.
Then FR we have found 2.20 centimeters. So centimeter gone first of all. 0.36 divided by 2.20. Okay. Now you remove the decimals. So
36 by 100.
36 by 100. Okay. Then here. So if I write 220 divided by how much?
100.
100. Okay, that's good. So 100 again gone. Right? So you have 36 divided by 220. Both are even numbers. So first of all, make use of 2. If you divide both by 2, what will you get? So this is 2 into 1 is 2. And then you get 16. So 2 into 8 is 16. This is 18, right? Again, 2 into 1, 2 into 1 and 0. So you're getting 18 upon 110. Again, both are even numbers. So again, you can reduce by 2. Yes.
Yes, ma'am.
Okay, so 2 into 9 is 18 and 110. That means 2 into 5 is 10 and then 1 remaining, again 10. So 55 you are getting. Oh, Sarah, one mistake we have done. 9 upon 55. I'm really sorry. In the first case, when I remove the decimal from the numerator, it's not 10, it's 110, isn't it? See?
Yeah, ma'am. Yeah.
So 110, if I reduce by 2, so again, I'm going to get
55.
yes, 110. So 9 by 55 I'll get. So here also I'm getting 9 by 55, 9 by 55. So therefore EF is actually, you know, parallel to QR.
No, 100. I didn't copy the first one.
So Sarah, after the class, you know, again do the calculation, close this copy, you make use of a different copy, do the calculation on your own. If you get stuck somewhere, then check. Okay.
Okay, ma'am.
But you know, practicing the calculation is very, very important. Otherwise, you will get stuck in the exams. You are not allowed to use calculators there.
Yeah. I'm done.
Okay, so both sides you should get 9 by 55. It's on your own how you do your calculation. Okay, please mark in your book. This question number 2, third part is important for the exams.
Okay, ma'am.
Yeah, third question now. So in figure 6.18, there's a figure. That's the figure here. So just, you know, very roughly I'm drawing it. This is A, B, C, and then you have D. This point is M, this is N, this is L. So first write down whatever is given always. E and F are points on side respectively for each. Oh, sorry. In figure 6.18, LM is parallel to CB. So LM is parallel to CB and LN is parallel to CD. Now to prove, what you have to prove, that AM upon AB is equal to AN upon AD, right?
Yes, ma'am.
Okay. Now how to do the proof? So from where to start? First of all, just see which exercise we are doing. This is the exercise which is based upon basic proportionality theorem. Clear?
Yes, ma'am.
So obviously we have to make use of BPT here. BPT means we need one parallel side. I mean, in a triangle, two sides we need parallel. We start with the given condition always. Just a minute. See, this is the first condition which is given, that LM is parallel
Ma'am?
to, yes.
Ma'am, shouldn't we write like in triangle ABC, LM is parallel to CB?
Okay, you can start. I was just explaining first of all, then I was supposed to write, but you can start from here also, that in triangle ABC. Okay, so LM is parallel to CB. I mean, this side is parallel to this side. Clear? So I can use BPT because LM is parallel to CB. So by basic proportionality theorem, AM upon MB is equal to AL upon LC. Is this clear?
Yes, ma'am.
Market result 1. Similarly, the other condition, LN is parallel to CD. That means this side is parallel to this side. So you take the other triangle. So in triangle ADC, your line LN is parallel to CD. So by BPT, this time your AN upon ND will be equal to AL upon LC. Clear? This is your result number 2. Now, if you look at your result number 1 and 2, both sides you are getting AL upon LC, AL upon LC in both the results. So RHS is same in both. That means their left hand side is also same. So from
equation 1 and 2, you get AM upon MB is equal to AN upon ND. Right?
Ma'am, but how MB is coming AM by MB?
So when I'm using, wait, when I'm using this triangle, Sarah, this one, yeah?
Yeah.
So ratio means this side upon this side is equal to this side upon this side. That's the basic proportionality theorem.
Yeah.
So AM upon MB is equal to AL upon LC. The question is not complete yet because I have to get AB here. Okay.
Yeah.
Okay. So far is it okay up till here?
Yeah.
Okay. Now we will do the remaining portion. So have you written? Shall I rub it?
No, ma'am.
Please note it down because I need some space.
Just 1 minute. Yeah, done.
Okay, done. So I'm just erasing from here. Now look, Sarah. In my result and in, to prove, just see, you have AM term here and I'm also getting a AM term here, right? And then you have AN here and then you have AN here. That means I have to disturb this thing, MB, and I have to disturb ND. So this is not I want. Clear?
Yes, ma'am.
Understood. So what I'll do is I'll just flip this equation. So I take the numerator to be the denominator. Both sides I can do. So in equation, I can do the same thing both sides. The equation doesn't change. Okay. So I've just flipped the equation. Any problem?
No, ma'am.
Okay. Now I'm adding 1 on both the sides. So I do MB upon AM plus 1 is equal to ND upon AN plus 1. So I can add same number both sides, doesn't matter. Equation doesn't change. Now I take LCM. So if I take 1 means I have 1 in the denominator, right?
Yeah.
So AM and 1 will give me LCM AM. Yes?
Yeah.
So AM, that means, 1 time it will go in LCM. So this 1 will be multiplied with the numerator. So it is 1 into MB. Is this okay?
Yeah.
And then in this one, the denominator will go AM times. Sorry, the LCM will go AM times. And this AM will be multiplied with your numerator. So this will be AM into 1. Is this understood, Sarah?
Yes,
Or
ma'am.
not? No, but if you have any sort of confusion, just tell me right now.
Can you tell me how to do this?
Yes, please. That's why I'm asking. Okay. Let me take some numbers. For example, I have 3 divided by 5 and plus 2. This is what I'm doing. Okay.
Yeah.
So just look at numbers, how we do it. So basically, when I don't have anything, that means I have 1 in the denominator. Yes. Now I will take LCM of 5 and 1. So ultimately I'll get 5. You can always check it if you want, just do. So 5 into 1 and 1. So that's it, over. So LCM is 5. Okay.
Yeah.
Okay. Now how we write it? So we see how many times this LCM is going in the denominator. So 5 into 1 is 5, right?
Yeah.
5 into 1 is 5. So this 1 will be multiplied with the numerator. So it will be 1 into 3. Clear? Plus.
Yeah.
Now how many times this LCM will go in the denominator? So 1 into 5 is 5. Yes. So 5 times it will go.
Yeah.
So this 5 will be multiplied with the numerator. So this will be 5 into 2. Getting the point?
So ma'am, is opposite, like if there's this number.
No, it's not always opposite. So have you understood this much?
Yeah.
Okay, now I take different examples. in this particular case, you know, you have 1 in the denominator, but you can also have some other number. For example, you have, let me take this 7 upon 2 plus 5 upon 3, let's take, right?
Yeah.
Now, how you will add, first step is to take LCM whenever you are adding or subtracting fractions. So take LCM of 2 and 3. What is the LCM? Tell me.
2 and 3, 3 to the 6.
6 is the LCM. Okay. Now, how will I write it? So 2, that means 3 times it is going, right?
Yeah.
So 3 into 7. That's how I write my numerator. Now in 3, how many times it is going?
3 times.
Oh, 3 into 3 is 9. 3 into 2 is 6, isn't it?
Yeah, yeah.
So 2 into 5. So it's not always opposite. Getting it? I mean, you can have any number. In that particular case, you were having 1, that's okay. But you can have any number. So you have to check how many times is it going. And that will be multiplied with the numerator. So it will be,
Yes, ma'am.
21 plus 10 divided by 6. Like that you have to do. Understood now?
Okay, yes, ma'am.
So that is why I'm saying calculations are so important. Getting it? Otherwise, you will
Yes,
get
ma'am.
stuck in the steps. You will not be able to proceed further. Right? So let me just erase the useless things from here. So that was my equation. So now I'm taking the LCM. So LCM is AM. So 1 time it will go, right? So 1
Yeah.
into MB is MB. And in this 1 in the denominator, it will go AM time, and AM into 1 is AM. So this is what I'm getting here. Understood?
Yeah.
Similarly, AN is the LCM here. So this is 1 time going, so ND, and this is AN time going. So AN into 1 is again AN. Any confusion? Or should
No.
I do it again? No?
Yeah.
Fine. I hope you are understanding now. I mean, you can practice on your own, Sarah. Just take examples. Like I took some examples and just try with numbers.
Yeah, ma'am.
Okay. Okay. Now, what is MB plus AM? Just look in the figure. What is MB plus AM?
ND by AN.
No, no, no. MB plus AM. MB means this thing, MB. And AM means this. So if I add the two, what will I get? I'm getting the complete side, right?
Yeah.
That means AB, isn't it?
Yes, ma'am. AB.
AB. So I get AB divided by AM. And what else? ND plus AN is how much?
ND plus AD.
AD. Good. AD by AN. Now you just check. You have to prove AM upon AB. I'm getting something reverse. AB by AM. Similarly, you have to show AN upon AD. I'm getting AD by AN. So you can flip the equation. So AM upon AB, both sides you can flip. AN upon AD. So this is same. Yeah, right?
Yeah.
This is same.
Yeah.
So you have proved. See, only calculations were important in this question. Otherwise, it was so easy.
Yeah.
Just note it down, please.
1 minute. Yeah, done. Done, ma'am.
All right. Now come to question number 4. In figure 6.19, so that's the figure in your book. Okay. DE is parallel to AC, right? So I'm just drawing a line DE, which is actually parallel to AC. So the blue is parallel to blue. That's how I'm drawing it. And this is DE. And DF is parallel to AE. So DF. Okay, AE is this, and then you have a line DF which is parallel. So I hope it is clear. The green is parallel to green, blue is parallel to blue. Yes?
Yeah.
Okay. So prove that this thing. Write down what is given first of all. DE is parallel to AC and DF is parallel to AE. Okay. To prove, you have to prove that BF upon FE is equal to BE upon EC. Okay, let's do the proof now. Okay, so always use whatever is given. So we start with one given condition, which is DE parallel to AC, right?
Yeah.
DE parallel to AC means blue line. So if I want to you make use of blue line, so which triangle I should take?
Triangle ABC.
ABC, good. Now in triangle ABC, DE is parallel to AC. So by Thales theorem or BPT, the ratios will be same. So I can write BD upon DA will be equal to BE upon EC. Is this clear? Because I'm using the blue line. So BE upon EC. Understood?
1 minute, let me
Yeah,
just
just look at the
mark
figure.
those.
Yeah, please look carefully in the figure. So because I'm using the full ABC triangle and the line DE is parallel. So that means this side upon this side will be equal to this side upon this side, isn't it?
Yeah.
Because DE is the breaking line. All right.
Yeah.
Okay. So far, mark this as your result number 1 because we can use it later. Now come to the green line in the figure.
Yeah.
So if I want to make use of green parallel lines, which triangle I should use?
Green parallel line ADC.
ADC, no. ADC is not a triangle, Sarah.
Then
Okay, AE is the base of the triangle, right? And DF is parallel to that line. So which triangle I should use? Which triangle is having the base AE? E for elephant.
ABE.
Good. In triangle ABE. Okay, that's good. So in triangle ABE, your line DF is parallel to AE, right? So again by
Yeah.
BPT. By BPT, therefore by BPT, I can write BD upon DA, right? One side of the triangle is equal to the other side. So because F is the breaking point, so BF upon FE. Is this clear?
Yes, ma'am.
Okay. Now compare 1 and 2. What can I write from 1 and 2? Tell me.
Just 1 minute. Yeah.
Hmm.
Uh,
Now look carefully at 1 and 2. What can I conclude?
that BD
Hmm.
by DA
Hmm.
is equals to one minute. Is equals to BA.
Okay, tell me what you are saying. BD upon DA. Yeah.
Yeah.
Equal to.
Um, 1 minute. BF
Hmm.
by FE.
By FE. But this is equation number 2, Sarah. Same equation number 2. But I want to combine equation 1 and 2. Okay, what is same in equation 1 and 2? Tell me. Is there anything which is same in equation 1 and 2?
Yeah, the BD by DA.
BD by DA is same. That means the left hand side of both the equation is same. That means their right hand side is also same, isn't it?
Yeah, yeah.
Yeah, so we will equate the right hand side. From equation 1 and 2. So BE upon EC will be equal to BF upon FE. Is this clear?
No, 1 minute. Let me see.
I mean, both the right hand side I'm equating because the left hand side is equal. So that means their RHS is also equal. Yes.
Yes, ma'am.
So this is also BD by DA. This is also BD by DA. Or you can write one line here, since LHS is same, RHS is also not same, equal. RHS is also equal. Clear?
Yes, ma'am.
In case, you are not able to understood later, so you can just write this line. So
Yeah.
I am equating the right hand side of both the equation because their left hand side is equal. So their right hand side will also be equal.
Yeah.
Okay. So that's the result I have got combining equation 1 and 2. Now, what can I conclude from this result? Now, again, go back to your figure and see what I'm getting. So I'm getting BE upon EC. That means this side, right? Upon this
Yeah.
side. Okay. Clear?
Yeah.
And BF upon FE. That means BF upon FE. This I'm getting. So what can I conclude from here? Oh, ultimately you have to show this only. Enough. You have proved it, right?
Yeah.
Okay, nothing else.
Ma'am, it should be opposite, right?
BE upon AC. It doesn't matter. It's equation. Left hand side is equal to right hand side. That means right hand side equal to left hand side.
Yes.
You can write it, no problem, but it means the same thing.
Yes, ma'am. Done.
Okay. Now question number 5. Right. This is again, sorry, interesting question. Question number 5. It can be asked in your exams also. 5. In figure, so there's a figure which is given. Let me just draw the figure. So you also draw it roughly in your copy. So first note, whatever is given. So this you have to show.
And we don't have to write show that, prove
To
that,
show.
or should.
It depends on the question. In the question, it is written show that, so we will show.
Okay.
Yeah.
Yeah.
Right. So let's do the proof or solution, whatever you call it. Right. So we start with the given condition. In every question, we do the same way. We start with the given condition. So it is given that DE is parallel to OQ. Now, where is DE? DE is this line, Sarah.
Yeah.
OQ is this line. Okay. So which triangle I should take if I want to use the basic proportionality theorem here?
POQ.
POQ, very good. So in triangle POQ, now DE is parallel to OQ. So what will I write? By BPT. Therefore, by BPT. What will I write? Tell me. Now the sides are in proportion. So what should I write? Okay, PE upon what?
EQ.
EQ. Okay, is equal to, tell me.
EQ. No.
I mean, see this triangle, only this triangle you are using, right? So
Yeah.
one side you have written P upon EQ. What is the other
P-
side of this triangle?
PO.
No,
PD.
O, PD upon
DO.
DO. Yes, that's good. Mark it 1. Okay.
Yeah.
Okay. Now go back to the second given condition. DF is parallel to OR. Now where is DF? DF is this. OR is this. So which triangle I should use now?
POR.
POR. Good. So in triangle POR, because the line DF is parallel to OR, so therefore by BPT, now you will tell me what should I write.
PO.
O is this, Sarah?
Oh yeah. PF
PF. Okay.
by FR.
Okay, good. Is equal to
PD
Hmm.
by DO.
Very good. DO. Mark it 2. Now again compare 1 and 2. What can I write from here? This time what is equal?
PD by DO.
PD by DO is equal. So what should I write as a result?
PE by EQ is equals to PF by FR.
Okay, good. Okay. Now what is PE? What is EQ? See in the figure again. PE means this, right?
Yeah.
EQ means this. Okay. Is equal to PF means this and FR means this. So some sides are coming in proportion. So which triangle I should use now? PE by EQ, I'm getting equal PF by FR. So which triangle?
PQR.
PQR. Very good. So in triangle PQR, now ratio I'm getting equal. So PE by EQ is equal to PF by FR. See, this time line is not parallel, but I'm getting the ratio to be equal. So what can I conclude from here?
That
So therefore, I mean, by converse of BPT, what should I conclude?
that 1 minute. 1 minute. Yeah.
Okay, what is basic proportionality theorem?
EF
Hmm.
is equals to QR.
Equal
Yeah.
to or parallel to?
Oh, sorry, parallel to QR.
QR. Okay, that's good. So this you were supposed to show.
Yeah.
Yeah.
Yes, ma'am.
Okay. So I think one more question we can take. We
Yeah.
have time. Sixth one. In figure 6.21. Okay, again one figure is given. This is again a good question. Something like this. So Yeah, that's the figure. Let me just mark the points here. This is PQR. Okay. This is O and ABC. Right. So start what is given. ABC are points. Please draw the figure quickly.
Yeah, done.
Okay. So now look at the question in your book. ABC are points on OQ, fine, such that AB is parallel to PQ. So it is given that AB is parallel to PQ. And one more thing is given. AC is parallel to PR. Yes. Okay. Now you have to show BC is parallel to QR. So it is like quite similar to the question number 6 we have already done.
Yeah.
Let's do the proof. So again, we will start with the given condition. AB is parallel to PQ. Now, where is AB? Where is PQ? Look in the figure. This is AB, right?
Yeah.
This is PQ.
POQ.
POQ, good. So in triangle POQ, AB is parallel to PQ. This is given. So therefore, by BPT, what can I write? Tell me. So what will I write?
OP.
OP is complete side, Sarah. We take proportion of sides.
1 minute.
I mean, look at this triangle like this. This is the front face, let's say this is O, P, and Q, right?
Yeah.
And this is your side AB. So what will I write if I am using BPT in this triangle?
PA
Okay.
by AO.
Okay.
Then OB.
No, if you are taking the lower side, so take the
Yeah,
lower
yeah.
one. Yeah.
QB
Okay.
by BO.
Yes. So that's how you will write. Okay. I mean, don't take on your own. Either take OA by AP is equal to OB by BQ, or you take the PA by O. I mean, reverse. All right. So mark this equation number 1. You can use this result later. Now make use of the second condition. AC parallel to PR. Which triangle I should use now?
AC by PR. POR.
Okay. In triangle POR. Okay. So AC is parallel to PR, which is given. So therefore, by BPT, what can I write now? Tell me.
Yeah. PA
Mm,
by AO.
mm,
RC
mm.
by CO.
Very good. This is second. Now from 1 and second, what can I write?
That QB by BO is equals to RC by CO.
Very good. Now see in the figure, what is QB, what is BO? And tell me which triangle now is he talking about?
QB by QOR. Triangle QOR.
Very good. So in triangle QOR, now I have QB by BO is equal to RC by CO. So what can I conclude?
That 1 minute.
So ratio is same. That means See the reverse here, Sarah.
Yes, ma'am.
The line was parallel and therefore the ratio is equal. Now do the opposite.
BC
Huh?
is parallel to QR.
Very good. Which theorem I'm using?
Converse.
Converse. Very good. By converse of BPT, line BC is parallel to QR. That's good. Please note it down.
Done, ma'am.
Okay, so from question number 7 onwards, we will continue in the next class. Okay.
Yes, ma'am.
And whenever you have an upcoming test, okay, next test it will be in July, right?
Sure.
Or when? When is your next test in the school?
I'm not sure.
Okay, so whenever